All right, in this lesson, we are talking about something called synthetic division. And so in the last lesson, we talked about long division in order to identify the quotient and remainder for division of polynomials. And so this warm-up will review that method. And so to set up your long division, write down your dividend, making sure if you have any missing terms, you use 0 as a placeholder, and your divisor. Okay, and so to do the long division, you're looking at this first term divided by this first term. And so 4x times 3x squared would get me back to 12x cubed. And so take that term and multiply it by each term in the divisor. And so 3x squared times 4x would give me 12x cubed, just like we wanted. 3x squared times 3 would give me a positive 9x squared. Okay, we're going to subtract this, and so I say draw the line, change all your signs, because essentially you're distributing a negative when you subtract polynomials. And so the first term should always cancel. Negative 11 and negative 9 is negative 20 for the x squared term, and then we just bring down the 9x, bring down the 18. Okay, and so now we are doing our first term divided by our first term, which would give us negative 5x. Negative 5x times 4x is negative 20x squared. Negative 5x times 3 is negative 15x. Draw your line, change all your signs. First term should always cancel. 9 and 15 is 24x, and then we just bring down the 18. And so now we're looking at our first term divided by our first term, which would just give us a positive 6. 6 times 4x is 24x. 6 times 3 is 18. And so when I draw my line, change all my signs, both terms cancel, leaving me with 0 as my remainder. And so the quotient is the 3x squared minus 5x plus 6, looking at this, and then the remainder is just 0. Okay, looking at our second example, the dividend x to the fourth plus x cubed plus 7x squared minus 6x plus 8. No terms are missing. We go 4, 3, 2, 1, 0. And then for our divisor, it's quadratic with no missing terms. Same drill. So x to the fourth divided by x squared is x squared. X squared times x squared gives me x to the fourth. X squared times 2x is 2x cubed, positive, and x squared times the 8 is 8x squared. Draw your line, subtract, change all your signs. First term cancels, and 1 minus 2 is negative 1 for the x cubed. 7 minus 8 is negative 1 for the x squared. Bring down your negative 6x, bring down your positive 8. First term divided by first term would give me negative 1x. Negative 1x times each term would give me negative 1x cubed. Negative 1x times 2 is negative 2x squared. And negative 1x times 8 is negative 8x. Draw your line, change all your signs. First term cancels. Negative 1 and 2 is positive 1x squared. Negative 6 and 8 is positive 2x. And then still have that plus 8 at the end. Okay, and now first term divided by first term gives me a 1. Let's clean this up a little bit. Okay, taking the 1 times each term in the divisor, we get x squared, 1x squared if you want. 1 times 2x is 2x. 1 times 8 is 8. When we draw our line, subtract, change all your signs, we end up with nothing left behind. So once again, we have a remainder of 0. So quotient is the x squared minus x plus 1, just leaving off that 1 here. You don't have to write that. And then once again, the remainder is 0. So for synthetic division, it's a shortcut. It goes really, really quick, and it's a shortcut you're going to really need. We're going to use it to factor later, but it only applies when your divisor is linear, meaning it's degree 1, and so you can write it in form ax plus b, okay? And so here's a diagram of how the synthetic division works, but let's just do some examples. And so for synthetic division, it's kind of like you do an upside down division sign. I call it a big L. Leave enough room for 2 rows of numbers because the first row is going to be your coefficients. Okay, and again, any missing terms would have a 0 as a placeholder. So just the coefficients, 12, negative 11, 9, kind of like when we were working with matrices. Just write down the numbers and don't lose any negatives. 0 as a placeholder. And so these are the coefficients of the dividend, the thing you were dividing, dividend. And then the number that goes here is the root of the divisor. And this only works for linear, okay? And so your root should just be one number. And so the root of this divisor would be negative 3. It's the opposite of what you see in the factor. And so the negative 3 would go outside, okay? And so from there, you bring down this first number. And then you take this number and you multiply it by the root. And so that gives me negative 36. And then you add down. So negative 11 and negative 36 is negative 47. Okay? And then you repeat this. You keep multiplying by the root. And so we're going to multiply negative 47 times negative 3. And we get 141. And so when we add these, you get 150. Take the 150, multiply it by the root. 150 times negative 3 is negative 450. And then when we add these, 18 and negative 450 is negative 432. And so I've been circling these just to show you that we're adding them. It looks kind of messy, so I'm gonna leave that off. We don't usually write that. And so this last number, I always box it off because that's your remainder. And then these numbers here are the coefficients of your quotient. Coefficients of quotient. And so since we're dividing degree 3 by degree 1, we always drop this degree by 1. And so this would be our x squared term, this would be our x term, and 150 would be our constant. And so our answer would be 12x squared minus 47x plus 150. And then our remainder is negative 4032, so we just write that over the divisor. Okay, and so we're going to do some more examples just because it's quick, and once you catch on, it's really quick, but if you miss it, it can be kind of confusing. Okay, and so for number 2, my coefficients are 1, negative 2, 4, and negative 1, making sure I'm not missing terms, 3, 2, 1, 0. So we won't need any placeholders. Clean that up. So do your big L. And so we have 1, negative 2, 4, negative 1. The root of my divisor, you set this equal to 0 and solve. And so it would be 2, x equals 2. Okay, don't forget, it's going to be the opposite. So bring down the 1. 1 times 2 is 2. Add, we get 0. 0 times 2 is 0. Add, we get 4. 4 times the 2 is 8. Add, and we get 7. Okay, and so box this number off. It's your remainder. And drop your degree by 1. So this is x squared, 0x, and then the plus 4. And then for our remainder, 7 over the divisor, which was x minus 2. Okay, on this next one, we are missing a term. We go straight from x cubed to x. And so this is really 2x cubed plus 0x squared plus 1x minus 3. And so when I set up for synthetic division, you need that placeholder. You'll be able to do this whole thing and not know you're doing anything wrong. So that's super important. And then the root of my divisor here would be -1. Bring down the 2. 2 times -1 is -2. Add the 0 and -2, we get -2. -2 times the -1 is +2. Add, we get 3. 3 times -1 is -3. Add, and we get -6. Okay, and so we drop our degree by 1. So this would be our x squared. This would be our x. This would be our constant. So our answer would be 2x squared minus 2x plus 3. And then for our remainder, -6 over the x plus 1. Okay, here identify the quotient and remainder when this dividend is divided by this divisor. Okay, and so we go from 4th power to 3rd to 2nd to 1, and so we're not missing any terms. And so I'm ready to write the coefficients. 6, -53, 32, 61, 19. Okay, and then the root of my divisor would be 8. Bring down the 6. 6 times 8 is 48. -53 and 48 is -5. -5 times 8 is -40. 32 and -40 is -8. -8 and 8 is -64. Add, we get -3. -3 times 8 is -24. 19 and -24 gives me -5. So just a reminder, we're adding this time. For long division, we subtract. For synthetic, we add. Okay, and so we were originally degree 4, so this means this is degree 3, and we're using the variable b. So that would be my b cubed, this would be b squared, this would be b, and then we'd have the -3 at the end. So 6b cubed minus 5b squared minus 8b minus 3 plus the remainder over the divisor, b minus 8. Okay, and so in these examples, our a value for the linear function was always 1. If you have a value in front of the x, that's going to change things. And so start the same way. Get your coefficients. Make sure you're not missing any terms. So 3, -7, 29, -9. Okay, so this time the root of my divisor would be a fraction 1/3. Okay, and so it's still going to work out nicely with the fraction, but there's going to be an added step at the end. Okay, so when I bring down the 3, 3 times 1/3 is 1. -7 plus 1 is -6. -6 and 1/3 is -2. 29 and -2 is 27. 27 and 1/3 is 9. Add, and we get 0. Okay, and so just thinking about if I were to write this as my solution, don't write this down because this is incorrect. We usually drop the degree by 1, so we get x squared, x constant. So if I wrote down that this was my quotient with remainder 0, I'm saying that this 3x squared minus 6x times the divisor will get me back to the original dividend. Okay, if 3x squared divided by this left me with a 3x squared, that can't work because we know 3x cubed divided by 3x would just give me x. Okay, 3x squared times this 3x would give me a 9x squared. And so what happens is whenever your root has a denominator, your entire quotient is scaled by the denominator. So you're going to have to divide by that denominator. Don't divide the remainder. That is your true remainder, so leave that alone. That will always be your true remainder. Don't touch the remainder, but divide each of these numbers to get your true coefficients. Okay, and so our actual answer has a 1, -2, and 9. And so my answer would be x squared minus 2x plus 9, which makes sense, okay? Because we know if we divide 3x cubed by 3x, we should just get an x squared. Okay, so we're going to do another one like that. And so my coefficients, 5, -9, 12, -12, and -4, not missing any terms. And then this time my root of the divisor would be 5x equals -1. So x equals -1 over 5. -1 over 5. Okay, same drill. Your numbers should work out nicely. So 5 times -1/5 is -1. -9 and -1 is -10. -10 and -1/5 is +2. Add, we get -10. -10 and -1/5 is +2. Add, and we get -2. Okay, so this time we do have a remainder, and we're going to leave it alone. And so our denominator here is 5. So we need to divide all of these numbers by 5. Just 5. Leave this negative alone. Ignore that. And so we get 1, -2, and -2 for our coefficients. Drop your degree by 1. So x squared minus 2x minus 2. And then we have that true remainder of -2. So don't touch that over the divisor, which was 5x plus 1. Okay. Last question says, which warm-up problem can be done using synthetic division? Okay, and so going back to the warm-up, we have divided by a linear. Here we have divided by a quadratic. So we cannot use synthetic division for dividing by a quadratic, but we can use it for dividing by a linear. Okay, and so we're going to redo this problem below using synthetic division and see if we get the same thing. So I'm going to copy this. And I'm going to copy the answer and see if we get the same thing. All right, so using synthetic division, we would write down the coefficients, 12, -11, 9, 18, careful for any missing terms. And then the root of my divisor would be -3/4. I did not set this up correctly. We need the L for synthetic. Okay, and then the root of the divisor. All right, so when you're multiplying by a fraction, you are actually dividing by the bottom number, the denominator, and multiplying by the numerator. Okay, so we're going to divide by 4, multiply by -3. So first, just bring down the 12. 12 divided by 4 is 3. times negative 3 is negative 9. Add these, you get negative 20. Negative 20 divided by 4 is 5, times negative 3 is negative 15. Add 9 and negative 15, or that should have been positive. Negative times negative is positive. 9 and 15 is 24. And then 24 divided by 4 is 6, times negative 3 is negative 18, and then 0. Okay, and so remember, everything's scaled by 4. So divide these by 4, leave your remainder alone, and we get 3, negative 5, and 6 for our coefficients of the quotient. Dropping our degree by 1, we get 3x squared minus 5x plus 6. And so if you notice, we got 3x squared minus 5x plus 6 for our quotient, and we got 0 for the remainder. And so this is just a little bit quicker than long division.